So when we're counting moles, atoms, molecules, you need to be able to use something called Avogadro's number in order to be successful with this. Whenever we're counting atoms or counting molecules, you're going to use Avogadro's number. Remember that it's just a overall, like it's like kind of like a value. It's like 1 dozen is 12. 1 mole is 6.022 times 10 to the 23. So it can either be atoms, molecules, particles, donuts, whatever. So hypothetically, 1 mole of iron is 6.022 times 10 to the 23 atoms of iron. So how can you write this out to be a conversion factor? So like before, 1 mole of Fe or anything over 6.022 times 10 to the 23 atoms of Fe, or you can flip it over to be 6.022 times 10 to the 23 atoms of Fe. Sorry, Mike Wachowski. Not sponsored by Disney or Monsters, Inc. 1 mole of iron. So how do you do this? How would you use that to convert? So if 18.0 grams of carbon to moles of carbon. So that's my known, this is my unknown. So remember, all of these can be done in one step. I guess 2 steps if you count the, so let's say 2 fractions for this. So 18.0 grams of carbon over 1, convert this 1 mole of carbon equals 12.01 grams of carbon, and that number I get from the periodic table. So 18.0 divided by 12.01, what am I going to get? I end up with 1.498 something. 3 sig figs, 3 sig figs. So it is 1.50 moles. And that's my final answer. So 1.50 moles of carbon. I know I had the blank up there, but I'm showing you what I'm expecting to see when you're doing these problems. 1.35 moles of magnesium to grams of magnesium. So 1.35 moles, mg, over 1. That's my known. My unknown is grams of magnesium. So I look at my periodic table. I see that the atomic mass, or the molar mass, because we're looking at moles, is 24.30. So remember that it is associated with the grams. So I know that moles mg has to be on the bottom. The only number you can use with moles for this is 1, and then 24.30 grams of mg. 1.35 times 24.30 equals 32.805. Sorry, thought it was something funny. 3 sig figs, so 32.8 grams of magnesium. .50 grams of copper, 2 atoms of copper. So remember, this can be done in 2 steps. So remember that, okay, well, I'll just do this way. So my known is 8.05 grams of copper over, it's a long line, over 1. So I put grams of copper on the bottom. The only number you can use with the grams is the molar mass of your specific element, atom, compound, whatever. 63.55. If we're looking at the atoms of this thing, that means we have to use Avogadro's number, 6.022 times 10 to the 23 atoms of copper. In the 2 fractions, I'm able to change it over to something else. Change it to like atoms or whatever. So 8.50 times 6.022 times 10 to the 23 divided by 63.55. For the sake of space, this is my answer that I get. I guess I'll put this on here. So 5.1187 E24, 63.55 on the bottom. So the answer I got was 8.0546 something E22. If you're doing this on your calculator and you don't get this, make sure you group your stuff correctly. So 3 sig figs. So 8.05 times 10 to the 22 atoms of copper. 15.0 grams of aluminum. Convert this over to moles. So 1 mole of aluminum on top. Al grams. Al is 26.98. Again, all the stuff with the grams, I'm just getting that from the periodic table. 15 divided by 26.98 equals 0.555 something. Oh, I'll put more numbers. 96 something. So the answer is going to be 3 sig figs, 0.556 moles of Al. Sorry, 2.35 moles of calcium, 2 grams of calcium. So my known, 1 mole of calcium on the bottom, and then calcium, the molar mass is 40.08 grams of calcium. Getting that from the periodic table, that's all. 2.35 times 40.08. I end up with 94.188 over 1, which is 94.188. 3 sig figs, so it's going to be 94.2 grams of calcium. 7.50 grams of iron, 2 atoms of iron. So still 2 steps. So the grams of iron, like we said, 55.85 grams of iron. And then atoms of iron. So we're just, because we're converting to the same substance, just looking at it different ways. So grams to atoms of the same thing, I can do it like this. 6.022 times 10 to the 23. 7.50 times 6.022 times 10 to the 23. This is 4.5165 E24 divided by 55, 25. 8.0868 E22. 3 sig figs, 8.09 times 10 to the 22 atoms of Fe. Compounds in the mole. So a little bit more. Now we're looking at not just elements, but we're looking at maybe molecules and compounds. So like different, either like Br2 or something, but also CO2, something like that. So 1 mole of that substance will equal the molar mass still, and that still equals Avogadro's number. You don't multiply it by anything because it's still in 1 mole. So when we're looking at our molar mass of a compound, you're going to have to get the mass of each element for the compound, and the correct number as well. So what is the molar mass of sulfur trioxide, SO3? It's there for you, but I need you to see how we get that. So the molar mass of sulfur trioxide. So I have 1s, so 1 times s is 32.06, plus 3 times 16.0. So when I add those up, I'm being thorough, even though it's on the paper, on the screen and on the paper, but make sure you guys are able to do this. So 80.06 grams per mole, that is the molar mass. In 1 mole of SO3, it equals 8.06 grams of SO3, and that also equals 6.022 times 10 to the 23 molecules of SO3. It is a molecule because there's more than one element attached to each other. If it was an atom, like by itself, that would be a different story. Find the molar mass of NH4 2SO4. So this one is ammonium sulfate. So I'm doing this one specifically because of the parentheses. So it's 2 times 14.01, which is the molar mass of nitrogen, plus 2 times 4, 8 times 1.008, plus S, which is 32.06, there's only one of those, plus 4 times 16. That's going to equal the molar mass of this. 2 times 14.01 plus 8 times 1.008 plus 32.06 plus 4 times 16. So the molar mass I get is 132.144 grams per mole. Don't worry about sig figs when you calculate this. This is okay. And even then, when you're looking at sig figs for your final answer, it's based on the question. And you're going to see some examples in a little bit. Find the molar mass of calcium phosphate. So you have 3 times calcium, which is 40.08, plus 2 times phosphorus, which is 30.97, plus 8 times 6, plus, my bad, 8 times 16. So 3 times 40.08 plus 2 times 30.97 plus 8 times 16. Yeah, this is a big number. So 3 times 40.08 is 120, so it makes sense. Plus 3 times 30.97 plus 8 times 16. So yeah, 310.18. 310.18 grams per mole. So how are we going to use these numbers? Well, once you use that, you can use it kind of like how we did before. You can use it as a conversion factor. So let's say we have 255 grams of ammonium sulfate. Convert this over to moles. So in 1 mole of NH4,2SO4, it is the molar mass of this, which is 132.144 grams of NH4,2SO4. So 255 divided by 132.144 would give us 1.9297 moles. So 3 sig figs. So it's going to be 1.93 moles of NH4,2SO4. "25 grams of calcium phosphate converting into molecules of calcium phosphate." So 25 grams of Ca3PO42. So I'm not going to use moles because that's 1 mole, but we're given molecules. So that means you're going to have to use Avogadro's number for this. So the molar mass is 310.18 grams of calcium phosphate. Molecules, so 6.022 times 10 to the 23 molecules. I'm going to abbreviate like this, molecules calcium phosphate. I don't know if that's the official one, but I'll work with it, it's fine. So 25 times 6.022 times 10 to the 23 in the numerator, which is 1.5055 E25 divided by 310.18. So this is going to be 4.8536 something E22. 2 sig figs. 4.9, do not forget your exponent, times 10 to the 22 molecules of calcium phosphate. Do not put moles, because don't put MOL, because that's not the correct abbreviation for molecule. Alrighty, so please do not take any shortcuts with this, gentlemen, because in the end, you're going to hurt yourselves when we're going to do more converting when it's going to be 3 or 4 steps, and then you're going to have to balance an equation prior to that. So please do not take any shortcuts. If you have any questions, please let me know. Thanks.